This is an undulated landform. This is the existing landform, as you can see. It starts from a 38-foot contour line, and then it goes all the way up to 48 feet. But our task is to create a road somewhere here, somewhere in the middle of this, where the highest point is 45.25 feet, and then it goes down in both ways. So this is going down from this to this, and also from this to this, and one way it's going down from 45.25 to 38.25, and the other way it's going down up until 43 feet. So that's the task. We need to put down this road on top of this landform. So let's see how we can do this. So the very first thing we need to understand is what's going on at the top. And that will give us a lot of references. So let's try to draw a section for the top. From what we can see, we have a 3-inch parabolic crown in the road, and then the road width is 40 feet. That's one. So let's try to draw that. So here, if I'm using a scale, and again, this is not in scale, but yeah, this is a conceptual section essentially, just for us to understand what's going on all through. So again, this is for the top. So this is for the HP at crown, essentially 45.25 feet. So as we know, if this is 40 feet from here to here, the crown height is 3 inches. Definitely it's way less in actual scale, but for us to understand conceptually, let's draw it like this. So this is 3 inches, and the road kind of looks like this. So somewhere in the middle, we have this crown. All right. Then also the road width was 40 feet. Let's try to put that down, because that's going to help us a lot. Then we can see that there are 2 shoulders here, and they are sloping 3% away from the road. Their width are 12 feet each. So shoulder, 3% down, 3% down. And from here to here, this is 12 feet. And this is also 12 feet. All right. And then we have a swale. Swale width was 9 inches, I think, yes, 9 inches deep. The swale width is 15 feet. So from here, if this is 15 feet, this is going 9 inches down. So this is 9 inches, and the swale would look like this. Awesome. And then we have a pedestrian, which is 6 inches up, and the width is 12 feet. The pedestrian doesn't have any slope. So again, this will go up somewhere here, and it will be a straight horizontal line. So essentially, our section would look something like this. Let's make it a little bold for us to understand what's going on. So this is our section where the crown height is 3 inches. There are 2 shoulders that are going down from the road. This swale is going 9 inches deep, and this is going 6 inches up. There's a tiny little human somewhere. Understand, this is a pedestrian. All right, so let's talk for this high point section? Like, what are the different elevation points that we have? So this is 3 inches. We know this is 45.25. So if we try to calculate how much is 3 inches in feet, let's do 3 divided by 25. Sorry, my bad. 3 divided by 12. That becomes 0.25 right here, as you can see. So in other words, if this is 45.25, this point right here, these points will be 45 feet. Okay, so at the very end corners of the road, end edges, or the edges of the road where the shoulder would start, we will have 245 feet elevation points. All right, that's one. Now we said shoulders are going 3% down both ways. So let's try to calculate for that. So for the shoulder, S is 3%. L is the width of the shoulder, which is 12 feet. We don't know the DE. We don't know how much it is going down. So let's try to calculate that. S equals DE divided by L into 100. That becomes DE equals S into L divided by 100. 3 into 12 divided by 100, which is 0.36 feet. Okay, so this is going 0.36 feet down. Let's try to do that. We know now that this is 45. So 45 minus 0.36 is 44.64. So we can confidently say that the shoulder edges are 44.64 and also 44.64. Now it's easy for the pedestrian. This is going 6 inches up. That means 0.5 feet up. So here the point will be 44.64 plus 0.5, which is 45.14. That's awesome. Now, what's 9 inches down? We don't know that. So let's try to calculate for that. This will again be 44.64. That's fine. But what's this? That's a good question. So let's try 9 divided by 12, because this is 9 inches, not 9 feet. So that becomes 0.75. And now let's do 44.64 minus that. So 44.64 minus 0.75. This becomes 43.89. And this is important. You'll understand why in a moment. So now we kind of have all the elevation points for this specific section. Let's draw the section nicely. So if we were trying to draw this section right here, so facing that way, and let's name this guy AA. So the section AA would look something like this. So that's one. And from here, we are getting one very important information, that the deepest this whale can go is 43.89. So this right here is 43.89. So that's the deepest point, sorry, that's the peak point of the swale. That's the highest the swale depth can go. So HP of swale. So let's write that down. All right. So that's part one, trying to figure out what can happen at the peak section. And that gave us a very important information that the highest the swale can go is 43.8. Now, let's try to figure out what's going on in terms of slope in both of these directions. And I will try to use two separate pages for this because there are two parts of this. If we were thinking in terms of 3D, the road has kind of a crease on the top and then it's going down. So there are essentially two problems compacted into one. This is a compound problem. So let's try to name these two parts. One would definitely be from 45.25 to 43 feet. So that's one. And the other would be 45.25 to 38.25. All right. So here we can see, and we're trying to figure out slopes for each, and then we'll try to figure out components for each of those. So for this, we can clearly see that the DE is this minus this. So slope calculation. DE is 45.25 minus 43. .25, and then we don't know the length to this, so we are going to use a scale for this at this point. So here's a quick tip. When measuring, you are going to divide, and when drawing, you're going to multiply. Sorry, when measuring, you're going to so we need to figure out the length for this, and we don't have that. That's not given to us, but it is given in the drawing because this drawing is done in a 132 inch equals 1 feet. So let's try to use our scale for that. So here we can see that we have a 180 scale and not a 132 scale. So let's try to use that. So from here we can see this is 24, 25.1 or 2. Let's settle for 25.2 for this. But the problem is, again, this is a 180 scale. So a 25.2 would means 25 times 4 because 32 divided by 8 becomes 4. So here's a quick tip for that. When measuring and using a smaller scale, you will multiply by the factor when trying to get the actual value out. And when drawing, you will try to get this in scale, so divide to get the actual value in this scale. So that's a quick tip: when measuring, multiply, and when drawing, divide. So we just got the L, which is 25.2 into 100, sorry, into a 4, because 32 divided by 8 equals 4. So that's why this is 4. So it becomes 100.8. So let's try to figure out our S. S equals DE divided by L into 100. So DE was 2.25 divided by 100.8 into 100. So that is 2.23. 2.23% slope this way. So write that down. This way. And let's try to figure out this. This is going down this way. And we just created a page for that. So let's try to keep stuff separated because this will get really messy if we don't. So DE for this part is 45.25 minus 38.25. It is 7. Let's try to figure out the length. So we are going to use the 1/8. So as we can see, this is 73.8 or 9. So let's settle for 73.8 because it's not quite 74 yet. So 73.8. So L is 73.8 times 4. And that's because, again, 32 divided by 8 equals 4. So let's try to calculate for that. So that's 295.2. So as we know, S equals DE divided by L into 100. So DE is 7, L is 295.2 times 100. And that becomes 2.37. Okay, so let's write that down as well. Percent this way. Okay, so that's for the slope of each of these. Great. Now let's try to find the 45 feet contour line for these two portions, because that's the immediate contour point, the immediate 1 foot contour point after 45.25. So let's tidy this up a little. I'll erase this a bit more so that there's no confusion on what's going on. There will be a lot of lines. Okay, so let's try. We're trying to figure out 45. So for this part, as we have figured out the S, and this is the longitudinal slope for each, so remember that. So for this part, we're trying to figure out the 45 now. DE is this minus 45. So 45.25 minus 45, which becomes 0.25. All right. S will always be this when talking about longitudinal direction for this part. So let's try to figure out the L, where in the crown that's gonna be. So that's gonna be the L. So S equals DE divided by L into 100. That makes L is DE divided by S into 100. So 0.25 divided by 2.23 into 100. So that's 11.21. And because we will be drawing this time, let's try to divide it by 4. And that's for our own purpose. So I will just keep it in a bracket so that that's not, that we know it's not the original. This is the drawing scale. So 2.8. Okay. So from here, we can try to get a 2.8 out. So 1, 2, and a little more. So somewhere here, we will kind of have our 2.8 for 45. So that's for this part. Now let's try to figure out for this part. So I should have written down, we are doing all this for the crown. DE is 45.25 minus 45. So 0.25. S is this. And let's try to figure out the L. So S equals DE divided by L into 100. L is DE divided by S into 100. And that becomes So 10.54. And again, we need to divide it by 4 for the drawing. 2.63. So let's try to put that down. So 2.63. So 1, 2, a little over 2.5. So that should be good. So that's for the 45 feet elevation point on top of the crowns. Now the question is, how is it going to happen in the edges? Now remember what we did in this section. You can see that these points were 45, right? Because this went 3 inches up and then these are going down. So we can very confidently say that for 45 at least, when we were drawing a perfect vertical line across the high point where it intersects with the road edge, that would be our 45 feet elevation point for the edge. So let's try to draw that now. So this is 45 feet for the both sides. So that's for the road. Now the question is, can any more 45 exist anywhere in this road? The honest answer is no, because this was the crease of the road. This was the overall high point, and from this it's going down and down. So there's no way a 45 can exist beyond this road edge. So we don't have to calculate any swale, we don't have to calculate for any shoulder in terms of 45. There might be something going on in terms of the there might be something going on in terms of the pedestrian. So let's think about it. As we can see, the pedestrian peak point was 45.14. So here we had a 45.14. So let's try to figure out for 45 in terms of pedestrian. So again, this was 45.14. So we are trying to figure out where the 45 will be. So for this person, again, let's try the pedestrian now. S is going to be the same, 2.37. DE should be 45.14 minus 45. So let's try that. DE is 45.14 minus 45, which is 0.14. So let's figure out the L. S is DE by L into 100. So L is DE by S into 100. So let's calculate that. So 5.90 or 5.91. And that should be from here to there. But again, this is 132, so we need to divide it by 4. So 1.47 or 1.48. That's the drawing scale, keeping it in brackets so that we can understand that's drawing and not the actual. So this was in this side. So 1.48 from here. Something like that. And let's calculate for the other side. So for the pedestrian, S is 2.23, DE is 0.14, because we're trying to figure out from 55.14 to 55, sorry, 45.14 to 45. And let's do the L is DE by S into 100. So that's 6.27. So let's divide that by 4. So let's draw that. Somewhere over here should be fine. So those two would essentially be our, and always when drawing a perfect vertical line or horizontal line, try to use a set square. So try to do that. Try to align it perfectly. Sorry. These are the times I wish I had a parallel scale, parallel bar. So that would be our 45 feet pedestrian contour line. So that's all for 45. It's a small island in the middle of the road. There's nothing else in the shoulder, in the swale, because everything is going down. Let's check for that again. Everything from this point was going down, and then we need to figure out for the pedestrian. So that's all for 45. That's the very basic. We already have figured out what's 45. And I should really write that down. This is 45. And this is also 45. Great. Now, what's going to be the DE for 44 in terms of from 45 to 44? That's going to be 1. So DE is 45 minus 44, which is 1. And then we're trying to figure out what's the S. So S, we already have figured out 2.23%. So we can very easily figure out the L. and this is from 45 to 44. So DE is 1, S is 2.23 multiplied by 100. So let's do the calculation. So that's 44.84, which is awesome because now we can chart the rest. So we can chart from 44 to 43 as well. But 43 is given, so that's pretty simple. So in order to draw this, again, we need to divide it by 4. That's 11.21. That should be right in the middle somewhere. So let's try to see if that's true. Should be. So from here to here we need to find out the 11. So 11 is here and then a little extra. So right here we have our 44. It's kind of in the middle, which is okay. Let's see. Yeah, that should work for us. Okay. So that's 45 in terms of crown. So let's try to figure the rest with this compass. So we can always use this distance and don't draw over and over again. We can come back here. We can come back here. And right now, this is our 44 feet contour line for the road. Great. Now let's do for the shoulder. Shoulder is 3% each way, so either way. So for that, and again, I should have write this down. This is for the road. Let's do for the shoulder. And this follows the previous steps that we did. It's already given in other videos and I'll link that down below. But here I'm just like using what I usually do. So for the shoulder, cross section is 3%. So shoulder cross section. And we could use the values from the sections. That's also fine. So if but let's do it one more time. That's fine. So cross section S is 3%. L is 12 feet. And let's do for the DE. So S is DE by L into 100. DE is S multiplied by L into 100. So 3 into 12 divided by 100, which is 0.36. All right. And that's for both. So this is going down 0.36, but that means it has to also come up 0.36. So that's the DE for length as well. So this DE is going to be the DE for the length. DE is 0.36. S for longitudinal was 2.23. So let's figure out. L is DE by S into 100. So 0.36 divided by 2.23 into 100. So that's 16.14. So again, if we want to draw this right, we have to divide it by 4. That's 4.03 or 4.04. It's so small. So 4.04 from here upwards, because shoulders are going down and this needs to go up in plan. So let's draw a vertical line. And from there, this goes 4.03 right here. So 4, little over 4, very close to 4. So that should be good. And that's true for both sides. Or let's try to make it a little more straight. Because I'm not using a parallel bird, this is not as accurate as I want it to be. But yeah, let's settle for that. So that's for the shoulder. Great. So let's figure out the same for the other side, and I'll speed this part up because we don't need that. This is the same for this, so I'll just try to copy and paste and use just a different slope. That's not right. Okay, so now we have 44 for each side, which is awesome. There's still one problem though. We have not calculated for the swale. And as you can see, there can be no 44 in the swale like this, because the swale lowest point is 43.89. So on the swale crown or the swale depth, there can be no 44, but still somewhere 44 is terminating. So let's try to figure it out with the basic swale calculation, and let's see how to determine where the contours for 44 will end. So essentially, if this is 44, another 44 will be somewhere here, another 44 elevation point would follow somewhere over here. So these two are 44. There's no confusion about that. These are the edges of the swale. So let's see where 44 ends. So we will use the standard uh, slope calculation for this. So let's try to figure it out. I'll go slow. So swale, and this is still going on for the 44. For 44. So as we know, the swale depth is 9 inches. So let's say that's true. So DE is 9 inches. which is 9 divided by 12, becomes 0.75. Okay. S is longitudinal, which is true for all kinds of longitudinal elements. So that's 2.23 for this part. So let's try to figure out L. L is going to be from here to where? So that's 33.63. Okay, so let's try to draw that, and you will see what I mean. It will kind of crisscross each other. And for drawing, let's divide that by 4. So that becomes 8.4. 1. Okay. So 8.4 from this line on top of this line. So 8.4 is somewhere here. You can see it's already crossed the crease over here. So this is again right now a conceptual. This is not accurate. We will correct this really soon. So this is the contour line for our swale for this part. This is gonna be, not yet. And let's figure out for the other side. Swale. Again, DE is 0.75. S is 2.37. So L is DE divided by S into 100. Which is 0.75 divided by 2.37 into 100. That is 31.64. So let's divide that by 4 for the drawing. 7.91. And that's from this towards this. So trying to find out the 1/8 here. 7.91. So almost an 8. Would be somewhere here. So it would, in an ideal world, look like this. But again, life is tough, so it won't look like this. What will happen instead, these two will connect. And that's it. Because this is going below 44, these two and anything in the middle will not exist. All right, but let's keep those so that we can track where they should be for the next ones. But yeah, essentially this would be our 44 feet contour line. with a low point in the middle of 43.89. And why was that? So let's go back one step again. Remember, when we were drawing the section, we found out that the highest point of the swale is going to be 43.89. So that's this 43.89. Let's make that bold. So this point right here is 43.89, and we figured that out with this calculation right here. So our 44s would look something like this. So the rest is simple. I'll speed this part up for the road part. So I'll just use a compass and keep drawing. Okay, so now we have drawn the road and all the contours that we need to draw this road. Now, what happens to the existing? Remember, these dotted and light contours were what was the existing site, and we are trying to put this road on top of the existing site. So here we can very clearly see there are some conflicts for the existing 45, 44, and yeah, some other stuff. So in reality, we would either have to cut or fill the site. So this is what we are trying to do in drawing right now, where we will try to create some smooth transitions between different contours that have intersected to remove those intersections. So here, the very first problem that we can see right here is that 45 is going all across 44 and everything else. So 45 can't be anything like this. This is our 44 right here. So let's try to draw the complete 44 first before we attempt to draw 45. It needs to be very smooth. So one of the 45 ending point would look something like this, and the other 44, this is going all the way over here. So let's say it would look kind of like this. Yeah, it's still not too great, so I'll try to make it even more smooth. So maybe somewhere over here. Yeah, that's a little smoother. So that's a 44. And now let's try doing 45. So 45 may look something like this now. And again, you can see it's intersecting 46. So let's create a smooth transition for 46. And that's our newly created contour lines. And that will follow for everything else. So let's speed this part up. This was 43. And then here we will just keep doing our smooth transition. Somewhere, hopefully they will meet. But this is how this portion of the road looks like. Now you can see there was a 45 over here, and we have two 45s over here. This is a 45, this is a 45. So there might be a small island or might not, depending on your choice, because this is very small. But definitely we will need to redo the 44. So the 44 new would look something like this. Let's make it a little more smooth. And then let's do for 43. sorry, this was 43, my bad. This needs to be redone. So a little more smooth. And the rest can continue like this. So I will try to make some smooth transitions. So this is where the cutting and filling would happen in real life. This is pretty close. So yeah, that's how you draw a road on top of a landform. There are some issues that's bound to happen, that's life, but keep calm, try to follow the logic, and I'm pretty sure you'll get there. So yeah, have fun.